Hi, welcome to another video. Today I'm talking about the ILI9341 display, a new font I've created specifically for this display, and you'll find the ILI9341 controller is closely related, if not the same, as the ST7735S controller that I demoed the other week. I developed a font for the Cytronics ST7735S. And when I wanted to bring that font over to this screen, looked at the datasheet, I thought, hello, most of the addresses are the same. The initialization, the voltage controls, and the gamma are slightly different, but all the addresses for writing to the memory, you have to preface the data for a picture, is the same as the ST7735S. So if you want the code for the ST7735S or the ILI9341, have a look in the show more. And I'll mention it now. If you do want a copy of the file and you do take it, you're welcome to share it, edit the file. You can't sell it. I don't agree with that. And you're welcome to make a donation for the time, the weeks or months I've spent developing fonts for these TFTs. So you might wonder, where am I going with this? So I created a font for this, and you can see it's very fast, no delays, otherwise I wouldn't be able to count hundredths of a second. So the font for that is obviously suitable for the yellow one, and the font for this was similar to the font for this. And I used a simple principle: every number has a footprint, and when a new number comes along, just that footprint is drawn again, the whole footprint. Yeah, that's what you learn at school, isn't it? When you learn to read and write, if you write a 1, if you haven't got an eraser, then you can write a 2 next to it. But MikroElektronica's formula is come along with a number 3, then a number 4, then a number 5. So why am I bitching about this? Because these compilers cost money. MikroC Pro for PIC, MikroC Pro for PIC 32, I'm sure that's well over £200, I forget, so many years ago. I had MikroC Pro for DS PIC, and the soldered joints sort of started falling apart within months, and I lost over £100. I sold it on eBay and got £90 for it. Poor quality soldering, which I also experienced on the programmer. The micro USB port fell off. This cost a couple £100. I'm sure this MikroC Pro for PIC 32 was going on for 3, I forget, plus the import tax to the UK. Then the programmer was I think $99 when I bought it. Then their development boards, the EasyPick version 7, then the EasyPick Fusion version 7. I've bought various clickboards over the years. So I've spent months creating these fonts. I've released them all on YouTube. I had a font suitable for this and the SSD 1963 driver, which used the pixel draw dot function. It hasn't been taken up because people think using the draw dot function is a waste of time. What really? What, so you'd sooner write a number, blank it in the background colour and write it again? Anyway, I've redeveloped the font for this ILI. It's now raw data, but that makes it only suitable for this, whereas the TFT dot was suitable for all colour displays that MikroElektronika do. Well, this sort of display, not the OLED. So in MikroElektronica's software, if you have to write a number and then delay it for a short period so you can see it, then write it again, the whole system is never going to be fast. You think I can put a delay on this, writing hundredths of a second? No. This has the ST's, the Cytronics 7735S controller, and when I came to copy the code and develop it for this, it was nearly identical. I thought, I'm onto a winner. So why am I going on about MikroElektronika? Well, you know I'm into electronics, and I get a post from Mauser Electronics, and there's a 2-page spread on MikroElektronica's CEO. 1,000 clickboards. Wow, fantastic. Really? What, so we can go and plug in all these clickboards and have an antiquated old font that you have to blank over and write again in 2021? Really? but you can plug in a clickboard, get a 16-bit ADC, 1 megabit sampling. But you can't show the data, not for once every few minutes, because your font takes so long. I mean, the whole issue started with this OLED display I got from Farnell, about £14. I only wanted to spend a few pound on some electronics, and to get free shipping got to spend over 20, so I bought this and had to develop a font for it. Because if you look at MikroElektronica's clickboard for this display, you can only draw pictures. Here's an example of a clickboard, the camera click. This came out months after my attempt of getting a $2 camera going. This cost $30 or $35 or £35 or more plus import tax, so it's not cheap. Uses the copyright protected or trademark click that seems to be as popular as I'm seeing this click implemented on many manufacturers' boards. Before I show you some clips on the computer screen, I'll run through some of the boards I've got and some of the issues I've had. So that's the $2 camera, got from China. I managed to get pictures. They weren't great, but I got pictures. An SSD 1963 800 by 480 screen. Months later, maybe even years later, I don't know when, but certainly later, this wasn't available. This camera click came out and I bought it and it worked a treat. So I thought, great, buy the Clicker 2 board and I can put it on there and have a mobile camera with a screen. This camera would not work on the Clicker 2 because the microcontroller has insufficient memory, or ROM. Is it ROM or RAM? I forget which. That controller would not run this camera. So this clicker board, waste of time. Here's a Bluetooth click. One of my first boards, Digipot click. So digital volume control, yeah, not bad, but used it once. Rotary click, that worked well, but a bit of a gimmick. This is a bug. So this is actually it's not a bug, it's an FM click, but this bugs me. I forget this was quite expensive, FM click. So as a radio, put headphones in. Took me ages to get the crystal running, has to be switched on with software. I bought this mistakenly thinking I could plug it into my Fusion board or the clicker board and run their demonstration software. No, they didn't do it for the PIC family, only for STM32 or some other family. So crap. A few of the microcontrollers. I've got a few of these CAN clickboards. They work well, but another microcontroller board. Some of these microcontrollers are not perfect because they have glitches within the hardware. Another one there. Obviously the one running the screen. I've got another one of these screens running there, ILI9341. And here's a brand new one from Farnell that I've never used. It says MikroE. Hopefully you can see it at the bottom. No, it doesn't say there. Oh, there. TFT Proto, MikroElektronika. See, I'm not afraid of buying their products. This one's a 16-bit parallel data, so it'll be twice as fast as that one. Let me show you some of the comments from this magazine. Here's a quick look at the front of that magazine from Mouser Electronics. I keep on saying Mouser, it's spelt Mouser, but when I phoned them up, they pronounce it Mouser. It says depot here in the UK, but all the parts come from the US. I've copied some of the text to a Word document in case I'm not allowed to show this material inside. I don't know. Let me show you some of the excerpts I've taken. So this first bit is a quote. If it's a quote, I'll show the quotation marks, otherwise I don't. So you can see with all the boards I've got, I've given away more than I own, so I'm not against the idea of the click. They are a good idea. It's just, I find some of the comments in the magazine objectionable. I'll show you why. So MikroElektronika, MikroE, is completely focused on time. Engineers must learn to value their time. They should be focused on increasing the quality of the whole project rather than just seeing a small piece of it. Okay, I can agree with that. He goes on to say there are many peripherals like UART, displays, RTC, EEPROM, etc. I'm sure that EEPROM should be EE, so electronically erasable, programmable, read-only memory. Anyway, so quote, "The challenge, therefore, is how to change peripherals easily. I was on holiday in Antalya, Turkey. In 15 days, I thought about this problem and all the possible interfaces." Really? I bet your missus was pleased with you. Or were you on holiday by yourself? I don't know. It's not for me to say. When I returned, I had the microbus, trademark, standard for sockets on development board, and the concept of clickboards that use the standard. Cool. So he was in Antalya, Turkey. What a coincidence. So he was in Antalya, Turkey, coming up with a solution for all the various peripherals. I was in Antalya, Turkey, and this is a plane taken off, 23rd of October 2013. Whilst I was in Turkey, you can see here, I was working on a problem, how to get a display showing reds using MikroElektronica's software, and how to overcome this font problem. Thought, how on earth can the font be writing over itself? Surely there must be a solution. So that was back in 2013. That's how long this problem's been going on for. Ever since I've got colour displays and MikroElektronica's software. So it's a shame we didn't meet up in Turkey. We could have sat down, had a coffee, and discussed why are you not updating your IDE and compiler. So he goes on to say, our big break came when we managed to persuade Microchip to include the microbus socket. Oh, so they had to be persuaded then. I go on to say, it's a crying shame you, MikroElektronika, didn't reciprocate in that deal and add all of Microchip's latest state-of-the-art microcontrollers to your portfolio. Instead, we have to make do with older generation 8-bit microcontrollers. I think there's at least half a dozen new 8-bit microcontrollers that aren't included in MikroElektronica's MikroC Pro for PIC. So MikroElektronika to date, so it's a 20th of May 21, he goes on to say, in order to keep up with the rate of one clipboard per day, we always have 250 clipboard projects on the go at any one time. That's a quote. And my YouTube friends, that's why MikroC Pro for PIC and MikroC Pro for PIC32 is out of date, full of flaws, and don't contain any of Microchip's latest PIC microcontrollers. They're concentrating on clipboards. They've had our money and don't need to give us any more. It's not like Windows. You pay for Windows, Microsoft Windows, once, give them £100 or so, and they update it forever. No, give these people like a couple of £100 per IDE, and that's it. It's never updated, or rarely updated. And when it is updated, it's then too late. Like people like Microchip have even later chips. So you're spending, if you're like me and you use MikroElektronika software, you're spending 200 odd plus for each IDE stroke compiler. Microchip's MPLAB X IDE is free for all 8, 16 and 32-bit PICs, but may not include the very latest and may not give you full optimization. So a bit like MikroC Pro for PIC then. So I must point out the Microchip's free IDE doesn't give you the full optimization or the very latest, or may not give you the very latest chips, only for the free edition. You can, if your company, buy a license, single licenses, multiple licenses, you then get full optimization and the very latest chips, just to make that clear. So he, the CEO of MikroElektronika, goes on to explain the design schematics and parts and assembly, and then you have to produce the software for a product. You then have to do all the bill of materials for hundreds of parts. But with their clipboards, they do all the work just for you and me. So this would be for your product. Spend 2 months in development or give us less than $50. So this is a quote. And you know the funny thing? There are still lots of engineers who choose to do it themselves. Really? I don't think you had a stepper motor click back in 2012 when I was showing people how to get a stepper motor going using raw data. No hidden files, no obscure language, easy to read, pulses on and off. An Arduino fanboy came along and said my code made the stepper motor work better than their own library. 2014, current sense amplifier. Don't know if you had a current sense amplifier back then. This was Microchip's lithium ion battery charger, which is just there. About £13. Back in 2014, I was demonstrating how to use a PIC, I think it was a 10F. So I had to use a compiler and IDE by someone else because your IDE didn't cover the particular chip. Oh yeah, here we are, PIC 10F202. I don't know if you cover it now, but back in 2014 you didn't. That's a demonstration of a simple radio-controlled switch. This is a 12-bit DAC back in 2014. Don't know if you had a DAC back then, probably did, I don't know. Bi-directional current sense amplifier back in 2014. Voice recognition, this just proof. So 2014, I bought that, it wasn't that great. Did you have an addressable lead ring clickboard back in 2014? Oh, this is a GSM. Yeah, I bought your GSM mobile click back in 2014. I actually gave it away with my development board. There we are. There's a section of the board. Linear Technologies adjustable oscillator 1 kHz to 33 MHz. January 15. Don't know if you had one of them then. Interrupt-driven Toshiba stepper motor driver. This is CAN SPI demonstration, great piece of kit. Digital potentiometer, so proud of that when I first got it. How times have changed. Oh, and the ILI9341, and I had to draw a box to get usable numbers on the screen. How ridiculous. 4x4 keypad demo with code and wiring. Not sure if you've got a keyboard click. OV7670 camera, so that was February 2015. Not sure when your camera click came out. I think it was after then. Pretty sure it was. ACS 712 measuring up to 31 amps. Not sure if you had something that could measure that sort of current back in 15. This is one of the few things I did struggle with, but I found it easier struggling with this ESP8266 Wi-Fi than your Wi-Fi board. And this was 10 times cheaper. So this was the camera click demo. But notice the text for Easy MX Pro version 7 for STM32. That, I feel, is where your resources are going, because they're certainly not being spent on the PIC microcontrollers. This was the new to programming Clicker 2 review. I slated it. So here's me demonstrating a Clicker 2 with a camera, and I think I'll go on to say it doesn't work on this Clicker 2 board, insufficient RAM or ROM. That's the radio module. By the looks of things, it didn't work because MikroElektronika didn't supply the software for PIC microcontrollers. So this project back in 2018, 7-inch screen, 800 by 480. That was fairly easy to implement. I had to write my own library or functions for the touchscreen because MikroElektronika don't cater for that particular touchscreen controller. It's not their flavour. So I had to spend hours and hours on that. And look, you can see there, so back in 2018, 62 reasons to choose MikroElekronika's Visual TFT. But I forgot that one. Yeah, that's an additional fee, something like £60-70 or more. And it's inferior to the STM32 or the ARM Visual TFT. PICs do not seem the flavour of the month or the flavour of any year or decade with MikroElektronika. And finally, to finish off my rant, this was back in 2017, the ILI9341 waveform generator. Would not work on your Clicker 2, would not work on this Fusion, because on your microbus socket, you're obviously aware, you do not pull out Microchip's chip select pin. So the chip cannot drive the chip select. And to drive that programmable waveform generator, you need a very fast chip select, and your software doesn't cut it. So why we spend hours on our devices instead of buying a clickboard? Because A, you didn't have them available, or B, your socket doesn't support the necessary pins we need. So that's what got me. Spend 2 months in development or give us less than $50. So for some of the boards, including that function generator, That did take me days and days to get going, and MikroElektronika didn't have a sine wave generator available back then. And I got it going and showed people how to get it going. I also tried the waveform generator on the Clicker 2, and on the Clicker 2 the chip select wasn't even included from the microcontroller. There wasn't a trace. So again, that's why I felt the Clicker 2 couldn't drive the camera, couldn't drive this waveform generator. So the Clicker 2 is just a waste of money. It's just, it's good for turning on LEDs. So when I see comments like this, and the funny thing, there's still lots of engineers who choose to do it themselves. So before I go, I'll show you a quick demonstration of the code I've set up for this ILI9341. So most of the comments you can see ST7735S, because I've copied them directly from that 128 by 128 colour screen you saw me demonstrate the other week. Got little notes in various places, all TFT controllers. You write the column address and then the row address, and then you'd normally send the data. But now on the ST7735S and this ILTEC ILI9341, you've got this command 2C, and that 2C means you're ready to write the data. And I've got a little comment there, 3 hours for this little item. And I mentioned in the previous video the 128 by 128, and now this ILI9341, you've got to preface the data with this number. It's in the data sheet. And it took me days to figure it out. I wasn't on it days and days solid. I'd just do other stuff and then come back to figure out why I couldn't get a picture on the screen. So that's important. If you're driving an ILI9341 or any of the ST7735 chips or similar, it's that data. You've got to preface it with that number there. But I'll put the C file in the show more. There's no hidden libraries. You don't even have to include MikroElektronica's TFT library. It's raw code. Unless, of course, you want to draw circles or squares, then you do have to include MikroElektronica's library. I haven't got round to that function yet. If you've seen any of my previous files for writing numbers on displays that, didn't have a language, the fastest way to write a number is to write the raw data, and all I've got is literally a case of lots of switch case statements, and then I write out every single character, like 0 to 9, then number string 8, number string 7. I've commented these others out because they're thousands position, 10,000, 100,000, because I'm not currently using them. And if you comment them out, A, it saves on ROM, and B, it stops the code running down each switch case. If you implement this code, it's essentially faster because A, the raw data is in front of you, so there's no call functions doing something in the background hidden in one of MikroElektronica's libraries. It's all raw data here. If there's a call function, that adds microseconds to your time. If there's any while one loops or for loops or do loops, that adds time. And you don't even have to do anything in the loop. If you've got a loop, if you've got a for loop, it's going to take time. So you might laugh at all the data, raw data, bit by bit. You could say bit banging, but that's the fastest method to get something onto the screen. I've made all the code available previously. This one's specifically for the ILI9341. You can come along and uncomment. If, for example, you only want an integer, you can comment out these sections, like clear the 100,000 position, so you don't need to clear that if you're only writing an int. So this write number, literally in the while one loop, I'm writing, uncomment that, that's the number you saw at the beginning of this video, write number, X, and then the position, and then the colour. Alternatively, if you include MikroElektronica's library, TFT set font, so let's draw it in line, you have to convert the number to a string so you can display it, then you write the string, and let me show you what that looks like. But before I come off this computer, all the characters like this. So this is number 0. You can call this number 0 directly. Or if you want to write long numbers, say an int coming from an ADC or some particular device, then you would use the write number function. Otherwise, if you just want to call one single number, you can call it write 0. And this now looks at the font, the number font only, or it gets the pixel color, gets the background color, looks at the font, and puts out the data if it's a pixel or a space. You only have to clear the screen once when you initialize the display, and that becomes the background color, and then you can obviously draw the number in any color you like. I've got something like 12 predefined colors. So that's like number 0, that's number 1, number 2. And what's important with this newer code, you can now use MikroElektronica's font creator, create a number font, so ASCII 48 to 57, drop it in here, call it a number font, but yeah, so this was Segmenti 14, 16 by 22, so I've dropped that number font in here, still called a number font, tell the program how many bytes long, and the size of the numbers, so 16 bytes, so 16 pixels wide, 22 high, I want one for the space, and that's it. You can change the font, put whatever font you like in this space. So that's me just defining the colours, black, red, orange, yellow, green, blue, violet, grey, white. That's the that's the resistor colour code you probably noticed if you're familiar. Magenta lime baby powder is like a sort of beige or off-white. Cyan, lavender blush, which is a pinky colour, and then another beige. And this black out, red out, that's what the program uses to actually clear the screen. Just writes that data. So notice it still says ST7735S. So if you want a black screen to start, look, you can see it puts out string of zeros, string of zeros. That's initializing the TFT. That's the write command. So chip select there, register select, data port, write, read, and then TFT write data. This is clocking the data into the display, these bits here. So initialize display. So again, ST7735S. But a lot of this initialization is specifically for the ILI9341, not the ST7735. But most of the registers were the same. I didn't want to change all these numbers to ILI9341. 2 lots of gamma settings there. These were found in the manual or the data sheet. And I've got the page numbers at various bits. So every time you write a number, this is setting the display and it writes the number. This is clear the screen, and you've got the choice of all the colours. So this is setting the pixel colour, and all the numbers call this function. So that call, that adds microseconds. But because I've got it listed once, it saves on program ROM. So you can see this write space, write number 9. So if you look at this number 9, get pixel colour. So it calls that colour function. Call costs time, microseconds. And then display the number, and that's writing the number. Write number 8. You will find this font is very fast, and there's no need to blank anything, so there's no flicker, which is rather, I just find amateurish. It's not just MikroElektronika with PIC microcontrollers. I've seen dozens and dozens of Arduino users suffer with it too. So that's I think this Adafruit library. It's a bit weak, needs redoing. And as you saw from the video in Turkey, I've had this problem always, forever, but I've just started fixing it now because I know how. So I'll leave you with a demonstration of the display with my function and then MikroElektronica's function. So this is my font for all the ILI9341 displays. There's a small 2 millisecond delay here, so you can actually see it counting. There we go. So I've taken out the delay, so it's actually too fast to see, and it's quite a sizable font. Obviously it looked bigger on the other display, but this is 320 by 240, so obviously it looks smaller. So that's no delay, my font. And let me show you what we pay for via MikroElektronica's IDE. There we go. You can see the picture's noticeably darker. That's with their settings, not mine. That's that segment font. It's writing 0 to 255 over and over again. There we go. So that's now being drawn in the background colour as well. Looks great, doesn't it? Not. So now let me put a 2 millisecond delay so that you can actually see the number. Bearing in mind you didn't need a delay with my font. You only needed a delay to actually see it counting, not to actually see the numbers. There we are. That's a 2 millisecond delay and it still looks awful. But that 2 milliseconds, I'm trying to write the code to give us a fast font. And as I say, every time you add a call or a do or while one, that costs you time. So putting 2 milliseconds here, you've just wasted a ton of time, because the IDE and compiler that we pay a lot of money for is, well, it's outdated, obsolete and needs updating. Why should I have to be doing this and giving you fonts? It's because MikroElektronika are too concerned with their clipboards and trying to make our life easy with clipboards. Well, they could make our life a whole lot easier if they redo their font and the method of writing it to the screen. Oh. So as I say, have a look at the C file. You're welcome to make a donation. I'll get myself a Costa coffee or a bag of Costa coffee beans. They cost a fortune nowadays. This has taken me months to develop, from bit banging months and months ago to now having neat call functions and trying to keep the code short so as not to use up too much ROM, but keep it fast. And if you think you can write MikroElektronica's font and you think you can draw a box, that's taking twice as long. Just draw one character and the footprint of one character. That's faster than drawing a box. It's probably going to be faster than drawing a whole line across the lot. This is just any other way. It's amateurish. You see it flickering. It's no good. Don't use call loops if you can avoid them. Don't use for loops if you can avoid them. Use a timer. Timer interrupts are very fast. Do loops, while loops and for loops are always checking to see if the condition is met. A timer interrupt is not checking anything. It just interrupts whatever's happening and does whatever you want it to do. In a timer interrupt you can get a number to increment and use that. Just a little tip. So when I see comments that engineers wasting time on devices that MikroElektronika already supply a clipboard for, that really annoys me when I've spent months and months, because their software doesn't know how to write a number properly. What, in 2021 we're still left with this? Garbage. And it's costing us a fortune. If you haven't learnt any C programming language, have a look at Microchip's IDE for 8, 16, 32-bit microcontrollers, and it's all free. So this has been a rant. I'm John B. Thanks for watching.